しもし。
Energy is all around us, a physical quantity that follows precise natural laws. Our universe has a finite amount of it. It's neither created nor destroyed, but it can take different forms such as kinetic or potential energy. It has different properties and formulas to be remembered. For instance, an LED desk lamp produces 6 watts. It transfers 6 joules of light energy per second. But let's jump back into space to look at our planet, its systems, and their energy flow. The Earth's physical system includes the atmosphere, hydrosphere, lithosphere, and biosphere. Energy moves in and out of each systems, and during any energy transfer between them, some is lost to the surroundings. As heat, light, sound, vibration, or movement, our planet's energy comes from internal energy and external sources. Geothermal energy from radioactive isotopes and rotational energy from the spinning of the Earth are internal sources of energy, while the Sun is the major external source, driving certain systems like our weather and climate. Sunlight warms the surface and atmosphere in varying amounts, and this causes convection, producing winds and influencing the ocean currents. While the infrared radiation, radiating out from the warm surface of the Earth, gets trapped by greenhouse gases and further affects the energy flow. Water includes many different kinds of substances, many of which occur in cycles throughout the biosphere. These substances include carbon, nitrogen, phosphorus, oxygen, and many other substances are used by organisms as they grow, reproduce, and die. This creates for many natural cycles within the biosphere. For example, here is the carbon cycle. We have a lot of evidence that describes the carbon flow throughout nature. We know that photosynthesis operates by taking carbon dioxide out of the air and using it to create sugars. The process of respiration, which happens in most eukaryotic organisms, releases carbon dioxide after the energy is harvested from the body's sugar. However, we also know that humans are altering this cycle with the burning of fossil fuels, adding massive amounts of carbon dioxide to the atmosphere. That changes how heat is trapped as well as how plants all over the world grow. However, there are many other cycles that can be explained by students. Some very interesting cycles are the nitrogen cycle, the water cycle, and the accumulation of toxins in top-level predators. Another thing is, an important difference is seen in energy. It does not cycle within an ecosystem. Instead, it enters the system when it is captured by primary producers and exits the system as it is used by a wide variety of organisms. The energy is transformed through the process being continually transformed into different bonds until it essentially escapes as heat and chemical energy. The most important process in nature for the flow of energy are seen in the opposing process of photosynthesis and respiration. Using a light-powered proton pump, chloroplasts harvest energy from the sun and place it into sugar. Small organisms and larger animals eat these plants using the energy to build their bodies. This energy passes through the ecosystem via the food web. Eventually, all the energy not used up by organisms before they die is used up by the decomposers in the soil. The process of photosynthesis and cellular respiration, where the carbon molecules used to store energy are released as carbon dioxide by respiration from both plants and animals. This frees up carbon dioxide to be used in photosynthesis, creating a closed system of carbon dioxide beneath the biosphere. However, energy is also present in anaerobic situations, such as near hydrothermal vents. Here, the primary energy source is not the sun, but the heat energy given off the hydrothermal vents. Heat energy is stored in sulfur bonds which can then be assessed by specialized anaerobic bacteria. The energy flow and ecosystems. The idea here is that whether there is oxygen or no oxygen, ecosystems can be built on any source of energy, whether that energy is gained through photosynthesis or through some other biochemical processes that extracts energy from the environment. This forms the energy basis of an ecosystem. Depending on how much energy is available, determines the overall structure of the ecosystem. Photosynthesis can provide enormous amounts of energy, though this energy is mitigated by other factors such as temperature, elevation, and latitude. Hydrothermal vents support not only small bacterial organisms, but an entire ecosystem of worms, crabs, and fish, such as those found deep within the earth that extract energy from mineral sources that have specialized to utilize the energy provided, while other forms of bacteria have evolved to extract energy from a large number of the other organic sources. Few of these bacteria produce large amounts of energy, limiting these ecosystems to a few types of specialized bacteria.
video.